Okay, problem 62, we are taking a look at a couple of different series. There are two things we want to do for this. First, I wanted to write it in sigma notation, and we want to find the sum. So, the first one here, first term is 47, next term is 34, and then 21. So it is actually decreasing by 13 each time. So my T of n equation for this first one would be first term is 47 minus 13 and minus 1. That is now written in first term form. To figure out the number of terms for this one, this is my last term. So when I put that in for my T of n, and I solve for n is my number of terms. So I'm going to subtract the 47 from both sides. I get a negative 130 equals negative 13 times n minus 1. Divide by negative 13. N minus 1 will equal 10. So n is 11. There are 11 terms to this series. So once I know that there are 11 terms of the series, I'm going to go through and use my formula. First term plus last term. So 47 plus a negative 83 times 11 terms divided by 2. That is going to end up being the sum is negative 198. All right, so writing this now in summation notation. So I'm going to use my sigma. I'm going to start with a value of 1, which means I can use my first term as 47 minus 13 and minus 1. Notice my variables are the same. Since I'm starting at 1, I'm going to end with my last term being 11. So that goes up top. So before I move on, a couple of quick things to point out with this sigma notation. Since we're doing first term form, it's easiest to start with 1 as your bottom number. And if you're starting with 1 at your bottom number, the top number is your number of terms. So that is the easiest way to go about this. Problem B. We are starting with 3, we're adding 7, then we're adding 7, then we're adding 7, and so on and so forth. So my first term form is 3 plus 7 and minus 1. Now here's why I wanted to write that out for this one. When I substitute a 1 into that formula, I get my first term. When I substitute a 2 in, I get that term. A 3 in, I get that term, and so on and so forth. And now this on the end tends to confuse students. Notice that's the same thing as this. So when I substitute in n, I get this, which means this has n terms. It does not have 3 plus 7, n minus 1 terms. It has n terms. This is just the way of generating those terms. So if we think of my sigma notation, I'm going to start with n equals 1. I'm going to actually switch that to p equals 1. And it's going to go to n number of terms. I'm just keeping those as different variables. My sum is 3 plus, or my first term form rather, is 3 plus 7. And now p minus 1, because these two have to match up. That is my summation notation for that. I now can figure out what the sum is going to be. So my first term is 3. My last term is 3 plus 7 and minus 1. I have n number of terms, and I'm going to divide that by 2. So the first thing I want to do is simplify this right here. So I'm going to distribute the 7 and I'm going to combine like terms. So I'm going to get 6 from adding those two, plus 7n minus 7 times n over 2, which gives me 7n minus 1 times n over 2, which when I distribute then, the sum for this is 7n squared minus n over 2. So that is now the sum of this series. Hope that helped.